All right, thanks everybody for joining today. My name is Jimmy Fielding, sales application engineer here at Purkeys. And joining me is Columbus Cali. Um, and I'll let you kind of talk about yourself a little
Yeah,
bit, Columbus.
absolutely. So yeah, as Jimmy was saying, my name is Columbus Cali. I'm a account manager for the Midwest here at Purkeys, um, as well, and we are both thrilled to be able to be here presenting for you today, and hopefully everybody walks away with a little bit more knowledge than they showed up with.
All right, so yeah, today we're going to talk about solar. Um, so power up with solar, extend battery life, and boost fleet sustainability. I know that's becoming more and more important for fleets today, and um, fleets now are doing everything they can to boost their sustainability number. Um, so we're going to kind of run through some things, and hopefully we can share some valuable information for you. So starting off, I'll kind of go through what we're going to talk about today. First off, why solar? We're going to go over some reasons to add solar to your application. Um, I've done a lot of traveling and visiting shops over the years, and solar is becoming more and more. Um, Technology is getting better, and it's becoming more and more of a thing that fleets are looking at. But I do still hear um, a lot of things from fleets that they're not so sure they want to move over to solar. Um, so hopefully we can kind of run through some of those things with you today and give you a better feeling about solar. The next thing we're going to go over is all the different applications, um, and it's not limited to the applications on here. Basically, you use solar to charge any battery, but we'll go over the ones that we deal with. We'll go over what options we have available, um, and then it's always you know to understand how much power you need. We can kind of run through some of those scenarios and how you can calculate how much power you actually need for your operation. Um, Retrofitting, um, in today's economy, um, likely fleets are looking at more and more retrofitting, versus buying new equipment. So we'll kind of walk through, how easy it is to retrofit an application, a trailer or tractor, with solar, and then some preventative maintenance stuff. Um, Solar is not a set and forget it type deal. Once it's installed, you really need to look at periodically checking those panels, make sure they are working. Um, make sure the dust and everything's cleared off the panels. So we'll kind of walk through some of that with you as well. So I'm
All
going
right.
to turn it over to Columbus.
Thanks, Jimmy. So why solar? That's always a big question. As Jimmy was saying, it's something that more and more fleets are starting to look into, not necessarily just to solve all their problems, but to kind of protect them on the back end a little bit and kind of give them a little bit more uh, steps forward hitting their sustainability goals. So what solar is going to do for you and your fleet is going to allow you to charge those batteries without having access or relying upon any kind of alternator output coming from the tractor or from any alternate generators or anything like that may be on your tractors or trailers. This is especially going to be beneficial for those trailers and tractors that are going to be either sitting on a lot for an extended period of time. As we know, the freight business is like a roller coaster these days. It's ups and downs. And then we've got a lot of trade cycles that are coming up. So you're going to find a lot of tractors that are going to end up sitting for an extended amount of time on these different cell lots, or they're being either decommissioned or swapped around. So this right here kind of helps to eliminate a lot of those parasitic loads, as well as keep those batteries topped off. So when you do happen to go out and try to crank up on there, you're not having to backtrack and go and get a jump starter or hook up another vehicle or something to it to kind of get those batteries up and going. Um, but as we keep on going through, also have to keep in mind of the seasons that we are going into. So summer is always going to be a huge factor on any kind of battery application, because that's typically when we start seeing, or we may not be seeing, a lot of issues that are going to be affecting those batteries throughout the long run. Now, if we don't take the proper attention to these batteries, during the summer months, when it finally starts hitting winter, we start seeing a lot of these temperatures starting to drop. That's when most fleets will start seeing a lot of their battery-related issues, either shorter lifespans or increased amount of jump starts, just because the batteries are no longer being able to hold a charge. And this is due to a couple different things. So it's going to increase the rate in which sulfation happens, but it's also going to do what they call plate shedding, which is something that we're going to touch on a little bit here, but it's unavoidable. It's going to happen to batteries as soon as they come off the manufacturing line, to the end of their lifespan. And though it's unavoidable, it can be not necessarily prevented, but it can be prolonged to the point to where we can easily manage that a little bit better. And that's where solar becomes a huge factor into this, because it's not seeing, that high and low discharge rate that you would find on any normal application without it. Just because, again, the lifespan of these batteries is going to be judged on how low it can be discharged and how quickly it can bounce back up. And then, just like a rubber band, if you stretch it and release it so many times, eventually it's going to break. And the same goes with batteries as well. So if you aren't taking the proper steps into getting your batteries topped off and making sure that they're maintained properly, you can kind of see a little bit shorter lifespan, but you also start to notice how some batteries may have shorted cells, and this is as a result of all of that in the long run.
Yeah, it's like taking a paper clip and bending it back and forth. You do that slowly, when the battery is fully charged, it's going to take a while for that paper clip to break, but
sure,
when you're cycling that battery at a low state of charge, you're basically taking that paper clip and bending it really fast, and that, Columbus talked about plate shedding. Those materials drop off the plates, and then you end up with a shorted battery. So, and that happens rapidly in the summertime, and usually you don't see that until that very first cold day. So.
Yeah, absolutely. But all of that being said, we have gone through and we've done the hard work for you already. Now, this is going to vary from fleet to fleet, but doing tests is something that we like to pride ourselves in being able to do, just because without the tests, we don't have the data to provide you. So what you see here on screen is two different fleets that we have done tests with. The tests span from either, from 6 to 12 months, and they saw measurable differences. Whether it's on performance of the vehicles or the savings that they had then accrued because of going through and participating in these solar tests, upwards to $40,000 or more on the maintenance side, and service costs for this particular test here for 50 tractors over 6 months. Nearly 50% fewer jump starts and battery or alternator and starter failures. As we all know, the more that a tractor starts and shuts off due to the auto start features or just rotating drivers or resets, you're just chipping off days, until this alternator or starter eventually fails. But not only are you saving on any of these mechanical maintenance parts, but you're also going to see a little bit of fuel savings in there. Can I put a dollar amount on that? Not. It'd be really hard to do that. But just knowing that you're going to be able to save, just because of, again, that decrease in the amount of auto starts that your tractor is going to have to go through, whether it's on your APU or electric APUs, any kind of alternate power supplies and stuff like that are going to be triggering those auto start features. This is going to be able to kind uh, mitigate that a little bit and keep it very minimal when it comes down to trying to factor in a lot of your savings.
One of the other things too that we kind of realized and fleets have realized is the technicians too. The time the technician has to walk out on the yard or even drive to an offsite location to do a jump start. A lot of times that time is not always tracked. So not having to do that does free up a lot of time and saves a lot of time and money.
Yeah, absolutely.
Just by not having to do that.
Yep. And it just takes a lot of focus on and puts it, somewhere else. But continuing on, we've got Fleet 1 here who was spending a significant amount of money replacing batteries due to parasitic loads. And this is something that is going to be more and more predominant, as we start developing future technology that's going into these trucks. And because even if you have a half an amp draw or a 1 amp draw due to parasitics on stuff that you just really can't disconnect from a battery, such as any kind of GPS or cameras or anything like that is always going to be pulling power around the clock, this helps to mitigate those issues. But as you can see here, we did a pretty sizable test. So 50 tractors that were equipped with solar panels, and then 50 tractors that did not have them. So over $40,000 in maintenance and service cost savings alone. And then tractors with solar incurred $0 in cost. Now, sure, there's going to be some variance between fleet to fleet depending on your use cases and what all is going on your tractors. But this is just a taste of what solar can potentially do for you and your fleet. And keep in mind, as you see there at the bottom, these results don't include any fuel savings or soft costs. So there's always more that can be added on top of that to really, really drive those savings for you and your fleets. Now, Fleet 2 was a little bit different in the data that they wanted to track. So they wanted to go exclusively off of VMRS codes because that's where they were seeing a lot of pain points. And so this was something that I know that not only this fleet faces, but more and more as the days go by, that a lot of people are seeing increased maintenance costs. This is going to be even more driven by some of the tariff increases, as well as just technician retention and stuff like that. So as a result, all of these codes, stacked on top of each other, inevitably resulted in poor cost per mile efficiency. So solar was able to help them out and being able to kind of help them bounce back, save on the fuel side, save on the maintenance side, and it really developed into a big win for this fleet here. But as we continue on through this, there is also tax credit incentives for those that choose to participate in solar. Now, this is going to require a little bit more research on your end for your particular fleet and see how it's going to benefit you in your company as well. But there are savings that can be applied to kind of help cushion the blow, because the initial cost of going into, installing solar on your entire fleet, whether you're doing tractors or trailers, or whether you're just looking to do an initial test, yes, Purkeys alone can help out with some of that. But there's also a lot that can be done, for your tax credits and stuff as well. Again, that is going to have to be some research of your own to be able to see who qualifies and how much you will be able to receive from this. But there are resources out there that will end up helping us.
All right, thank you, Columbus. So I'm going to kind of dive a little bit into the applications, all the different applications that we deal with. Again, it's not limited to these applications. Essentially, you can charge any battery off solar, and we've had a few odd ones over the years, but we'll kind of go through the the four main ones here. So we have a truck, a tractor application to charge the tractor batteries, which can add hours to your APU runtime. Lift gates is a big one. We all know that the lift gate is a big power demand. So,
Absolutely.
And when that gate's stuck on the ground, usually ends up being at least $1,000 road cost. So anything you can add to those charging of the liftgate batteries, you should do it. But yeah, increasing charging opportunities, reefer or heater, again, ensuring battery life and saving fuel. And we'll kind of dive a little bit more into that. Electric pallet jacks is a bigger one. It's becoming more and more of a common thing to be able to charge electric pallet jacks, inside the trailer, which we do have a separate product for that called taps. But a lot of fleets are wanting, some flexibility to be able to be independent from the tractor. So we have a couple different ways we can pull power. We pull it from the tractor dual pole, or we can pull it from the liftgate batteries. Solar is not going to direct charge to those pallet jacks, but whatever power source you're pulling from, whether it be liftgate batteries or the truck batteries, we can help supplement and replenish a lot of that power that's being drained from those batteries.
Absolutely. And not only that, it also, it's kind of focusing on the pallet jacks there for a minute, but it also frees up a lot of warehouse space. So you see a lot more companies that are trying to either consolidate and kind of become a little bit more efficient in both the workspace as well as their fleet assets. So this just allows a little bit of a unity between, pallet jacks and assigned trailers, or if you've got a trailer that's married to a certain tractor for a certain driver, it kind of helps to kind of streamline it a little bit easier. And plus, not having to pull a pallet jack out and then swap batteries constantly it's a no-brainer there.
So sleeper tractor, again, you're going to see a common theme here: increased life of the batteries. Again, cycling those batteries, at a low state of charge, like Columbus mentioned earlier at the beginning of the presentation, that's where you do all your damage. So, solar is a great way to for opportunity charging.
Yeah,
I hear a lot of fleets saying, "Well, my stuff never sits." At some point, it's likely going to sit, and that's where it really does wonders. Again, it's free energy once it's installed, so why not take advantage of that? Provide better driver comfort. The inverter, most sleeper cabs have a power inverter that pulls off that truck battery.
Mm-hmm.
Again, we're robbing energy from that battery. We got to replenish it somehow. Solar is a great way to do that.
Absolutely.
Long run time for the EPU between engine starts. So keeping that engine from starting, there's some fuel savings there. But again, it all goes back to cycling that battery at as high a state of charge as possible.
Absolutely.
Trailer application, for a liftgate, we've seen a lot of great success with this application. And it's again, when those trailers are, back at headquarters or at the, return from their route and just sit, solar's done wonders for, replenishing what they use throughout the day. Now,
absolutely.
Now, solar, it really depends on the application. We typically don't ever see a fleet that can only charge liftgate batteries off solar, but it really depends on, how your operation works. If they do sit for really extended periods of time and with very little cycling of the liftgate, you could probably do it with just solar. And we'll kind of go over later, how to calculate how much power you need, but solars work great for a liftgate application.
I mean, it really has, and as you were saying, there are some fleets out there that can rely just on solar, but you never really know, again, how much you need. until you start factoring in everything like we're going to be doing here shortly. But the big thing to notice is that, these solar kits that you'll find in the market these days are majority of them are very customizable. So you can start low and then just continue to build upon that to find what is going to work best for you.
But another key element to lift gates is they have pump motors, they have solenoids, all those electrical components that really do not like or don't last with that low of voltage.
Sure.
So if you're cycling at a low state of charge, there's voltage drop to all those components, so it's going to see even lower voltage, and that's what decreases the life of those components. So solar is a great way to, it's like filling up the gas tank. That solar panel is basically up there when it's sitting, filling up your gas tank, so you can start the next day with a full tank.
Wish I could find something that'll do that to my truck.
Straight truck is another good application. Again, increased life of batteries, reduce jump starts. Another good thing is installed on the cab so that the unit gets a benefit of solar while waiting for the box to be installed. That's a big one. So you got chassis sitting on a yard at an OEM, waiting for that box. They're just sitting there. Oftentimes there's a battery sitting there too. So it's going to discharge over time.
Absolutely.
So adding solar is a good way to keep them topped off and kind of kill some of those parasitic loads that are there and never off. So we've seen a great benefit there.
Yeah, definitely. And then not only that, it's and this is just across the board. If you're getting solar put on your equipment at the manufacturer, there's no telling how long it's going to end up sitting before it actually hits your location, or until it's being put in service. And there's been so many times that I've seen trailers and hit a location and the liftgate batteries be completely shot, and the trailer was just built. Or trucks needing to be put into transit to make it to a location, and they're having to constantly swap out batteries. So anything is preventative maintenance before preventative maintenance, I guess you could say.
Reefer application, we have solar in reefer applications as well. Biggest one there is offsetting a lot of the parasitic loads. There's a lot of parasitic loads on a reefer, but solar does wonders for keeping that unit ready for operation. Most of them have telematics now, which is a load on the battery. So solars work great for kind of counteracting that parasitic load of the tracking devices.
Definitely.
Now here's another interesting one. You got a heater, similar to a reefer. It's got a diesel engine. It's got a battery. It's mounted way up high on that trailer. Oftentimes, obviously it's seasonal as well. Summer months, that box you see in the picture up there with the battery inside that starts that diesel engine, it's just sitting there. And a lot of times, often nothing is charging that battery. It's even been an HR issue that fleets have had to go out and either replace batteries up high or charge them somehow.
Right.
So we've seen solar do wonders for this application, because when winter rolls around, that battery is ready to roll and can start that engine.
No kidding. I'll just go ahead and factor in a $300 to $500 battery, every winter.
But it does become an HR issue if
it does.
When you're having to climb up a ladder to get up there to maintenance that battery.
And batteries aren't getting any lighter.
Electric pallet jacks, spoke briefly about that earlier. But solar can do wonders to replenish that power that you're pulling from either the liftgate batteries or the truck batteries. Basically replenish that power you're pulling using solar. Again, we won't dive in deep on the taps. Taps is a great product to keep those pallet jacks charged. Again, that's another opportunity way to charge batteries.
Sure.
But again, kind of going over the common theme is keeping those batteries as close to 100% state of charge as possible. So now we're going to kind of go into some retrofitting. It all starts with the install. Even with our stuff, I've seen gone out to many shops to inspect solar that's been installed. If it's not installed properly from the beginning, and if these steps aren't taken, it's not going to last. But in the grand scheme of things, it's really not that difficult of an install.
No, not at all.
And it can be done, outside of a factory install.
Yeah. I can't tell you how many of these panels that I've put on in different shops or on lots. And plus, if you act now, you get a good tan out of it too.
But really easy install. Clean the tractor or the trailer top, or whatever device application you're installing this on. You got to make sure that surface is clean. All of our panels, most of our panels, come with a adhesive line backing, so you want to make sure it's going to stick to that. Now, we have had some trailer applications where you are dealing with translucent roofs. Just the normal cleaning methods, using alcohol or Scotch-Brite to scuff up the surface, typically don't work on a
No.
translucent roof, because we've had experience with that. But there are some primers out there, and we, again, in our installation guide, we have all these steps lined out for you. But it's still important to make sure that surface is cleaned. Place in the desired location. Once it's clean, press that self-adhesive panel into place. Use, and we say mechanical fasteners. More often than not, it's all done with the adhesive backing. And then mount the solar controller in the battery box, whether that's the truck battery box or the liftgate battery box. We'll kind of go over that in more detail here shortly. You have a 2-conductor harness that connects to the solar panels, already terminated with solar connectors, and then you route that to the controller, which we leave that end. We don't terminate that in because you may have to cut it to length, and then connect it to your solar controller, and then connect your solar controller power and ground to the batteries. Pretty simple install. There are some things to take into consideration, when you're talking panel placement. Obviously, you want to avoid common impact areas. On top of a tractor, as you see in the pictures, typically isn't a high impact area. But when you're talking about trailers, that's a different story. When we first started doing solar, we put all of our panels at the front of the trailer. Quickly found out that that's really probably not the best spot to put panels. For one, you have to route the cabling, and typically it's down the front of the trailer. But the front of the trailer, that's the first place it's going to get impacted, whether it's a bridge or a gas station awning. Not typically the best place to mount it.
No, not necessarily.
Putting it at the rear of the trailer, the panels have a better chance to live. You can utilize the trailer channels or even the liftgate channels to route all your cabling.
Mm-hmm.
Just makes a really clean install.
Really, really does.
So cable routing, you want to make sure, obviously, but you want to make sure it's clear from tree limbs or anything that could snag the cables. We include all the cable clamps and everything to secure the cabling. Again, avoid those common impact areas. On a trailer application, same thing. Really any application.
Yeah.
You got to make sure nothing's going to hit it. But you can kind of see here where we're putting these panels on the two right pictures. Put the panels at the rear, and we utilize the
little
trough and the side channel to run your cabling down. And that little trough is a good place to tuck all your cabling and secure it.
Yeah, it just keeps a lot of it, a little less exposed, and then by utilizing some of the holes that are already punched there, that you've already got your existing wiring and stuff from your marker lights, something like that, just kind of streamlines the process a little bit, because we all know that drilling through stainless is pretty easy, right? Yeah. So any kind of shortcuts and stuff that we can make while still keeping everything as efficient and safe as possible is where we're going to try to guide you. And that goes for tractor side too, as you can see again, from what Jimmy was saying on the left-hand side of those pictures. We're already utilizing some of the existing mounting bolts that's for that fairing, and then being able to attach our clips and everything. It just makes it to where we're not having to put any more holes into any of these pieces of equipment than we need to, hence the adhesive backing on there. And trust me, if you had any kind of second guesses about that adhesive, once it's down, it's down. It is very, very tough to get that stuff up.
Yeah, if you end up with a defective panel, you're either going to have to put a new panel on top of it or one next to it. And all of our panels are, you can, add Y splitters to add additional panels, and that really kind of go into how much power you need, which we'll talk about shortly. But we also include edge tape, is what we're calling it.
Yeah.
It's about as good as the adhesive on the back of the panels, but it really just keeps the any water from getting underneath the edges of the panel.
And it's good that you brought up, if a panel goes out or a panel gets damaged, because again, that's always been a big question too, is if this panel gets damaged, do I lose, all of my functionality from this panel? And the really nice thing about, how far technology has come these days is that, you can take a hole in one of these panels, and because of all the redundancies within how it's all structured, you may only lose 20 to 25% of that panel, depending on where it was damaged. But you're at least going to be able to get something out of it.
Mm-hmm. Yeah, the technology has come a long ways, and there's a lot of built-in redundancies to still get use out of the panel if any part of it's damaged. So the next thing you have is the controller itself, which I'll go into detail on the different types, but we use a MPPT solar controller. This one here pictured is a 15 amp. We also have a 20 amp. But some things you need to know about mounting them inside of a battery box, and things we've learned is it needs to be mounted in a manner that it's not going to fall onto any of the battery connections. We've had some instances where it was mounted on the roof of the battery box, and it wasn't mounted properly, so the controller actually fell and shorted out against the battery. So you just want to make sure it's mounted in a safe way that it's not going to short out on the battery. There's indicators on the front of that solar controller. As you can see, there's also a decal that explains what those lights mean. But you want to make sure that's visible to the operator. Make sure they can look at it and see that if it's actually charging, or what the current state is of the controller. So I'll let Columbus kind of walk through all the different products that we offer on solar. And
yeah, absolutely. So starting from left to right, we've got our solar bolt controller. As Jimmy was saying, we've got a 20 amp version as well as a 15 amp version. The one pictured here is going to be our 15 amp, and our 20 amps just a little bit more bulky, but it's still going to be able to function the same cabling, same pinouts, as well as the same LED descriptions. In the middle here is we have our solar dart, This is going to be for our 50-watt panels, which is more commonly found on any kind of reefer application. Now, I've seen a lot of use cases with this one in particular, whether if they're just trying to keep a independent battery charged up for a service truck, or using it as more of a parasitic load eliminator. That is one that has been really good. And then going into our solar dash, this was designed for trucks that are, again, either waiting to be put into service or have just gotten taken out of service and they're sitting on a cell lot. Essentially, what the panel is going to do is just like the name states, it is going to be solar for your dash of your truck. So it is going to come equipped with a cigarette plug or some ring terminals or some battery clamps that you would then be able to just either plug in and throw it up on the dash and forget about it, and have to be worry-free of any kind of parasitic loads drawing those batteries down, or you could wire it directly up. For all of you boat owners, it does help with that as well. But skipping back to our solar bolt there, one thing I did not cover is the versatility that these things have. So when it comes down to the trailer side lineup, we've got everything from 110 watts up to 330 watts. And when we are starting to talk about tractors, we have everything from 110 watts that jumps up well above 500. So whatever your use case, there is always going to be something out there that is going to be able to fill that need, or be able to provide you the support that you're looking for your fleet. And again, as Jimmy and I have both been saying, none of these are limited to just the trailer and the tractor applications, because service trucks, school buses, anything that has a battery that needs to be maintained, topped off, or charged, solar is going to be your best friend. It's not going to be something that is going to be able to constantly be able to counteract some of these heavy use cases. So if you've got a 28-foot pup or a 53-foot that's constantly having short stops in a metropolitan area, for instance, it may not be able to provide everything, but it is going to take a lot of stress off your tractor that is going to be putting a lot of work in to kind of keep those batteries topped off on there. So it works great as that very supporting role, or just a nice counterpart for your charging. Now, when we start talking about these controllers, so you've got a toss-up. It's going to be MPPT versus PWM. So MPPT actually stands for maximum power point tracking. Now, these are typically going to be a little bit more efficient, but with that comes a higher price point. So if you're wanting the best of the best, then this is going to be your avenue. And I think you would be surprised when you see where it says higher price point. It doesn't always mean like you're going to be paying, hundreds of thousands of dollars or anything more like that. But it is going to be a little bit more compared to the PWM, or your pulse width modulation. Typically, these are going to be more cost effective with a slightly less energy efficient output. But again, for those higher use cases or those higher power demanding applications, you're not going to see a whole lot of pulse width modulation from there. These are primarily going to be what you would see for your reefer applications and your tractor applications that are just going to be sitting and you're using solar to be able to be a parasitic load mitigator. Now, the solar bolt itself is everybody's go-to when it comes down to, I want to get into solar. I want to see how this is going to affect my fleet. I've got X amount of lift gates, or I've got X amount of auxiliary batteries that I'm trying to maintain. This is the one that always catches a lot of attention because of how customizable it can be. As you can see, and Jimmy has stated about it before, we do have different options. All of our kits are expandable. For the trailer side, meaning that, you can start with 110 watts. And if that's not meeting your needs, we can step that up to 220 or to 330 with just the simple addition of Y splitters and additional panels. Now, when it comes down to our tractors, again, we start out at 100 to 110 watts, and then we can work our way up to that 550 watt range on both 12 volt and 24 volt. So we're trying to stay up with the times, but the biggest thing is we're constantly learning and adapting to the ever-changing industry that we are all so proud to be a part of. Now, touching a little bit on the Solar Dash and Solar Dart, these again are going to start, with our Solar Dash at 20 watt panel. Again, it's primarily designed for eliminating those parasitic loads and being able to keep your batteries where you left them when you pretty much decommissioned or took the time to park that equipment. And then we've got our Solar Dart that is going to be our 50 watt panel. These are going to be found on your work trucks, on your reefers or your heaters, something that may not require near as much as far as power input, but something to help, kind of ease the pain a little bit. Both of these are going to be coming with your pulse width modulation controllers or your PWM controllers. Again, these are going to be 12 volt and 24 volt compatible. And they're also going to come with your alligator clips or your battery clamps, a DC plug for your cigarette lighter that's in the cab there, and ring terminal if you want to attach it to the batteries themselves, as well as cable extensions, because again, you may be working with something that may require 10 to 15 to 20 feet of cabling, or you just want to route it a certain way. We want to be able to kind of accommodate your needs in that department as well.
Yeah, I've had a lot of success with the Solar Dart, which is the 50 watt panel.
Absolutely. For
that heater application, because they do sit.
And I've seen it a lot for the reefer applications. Yep. Because again, reefers do have an auto start feature as well. And again, though this is not going to be pushing as much as what our heavier kits would do, it is still going to be eliminating those parasitic loads, putting a little bit back into the battery, and inevitably decreasing the wear and tear on that diesel engine for your reefer or your heater, as well as preventing a lot of those auto starts, which is going to, later on down the road, start accruing more cost. So now this is going to lead us into our first poll question, or maybe in our second one. Not quite. Oh, first one? Okay. So does your fleet currently use solar on any of the following? A, being your trucks, B, being your reefers, C, for lift gates, or D, for straight trucks? Now, I wish that we had a multiple selection option on here, because I think that, everyone could benefit from this on any fleet, really.
So we'll give you a few more seconds to answer. Oh, we can hover over and see the results. There we go. Yeah, there it is. Yeah. So it looks like we've got a few more submitting their answer. I think we're ready.
Yeah, looks about right. Kind of a split 50-50. That's really good to see. But yeah, as we've been talking about through this whole webinar, your trucks and your lift gates, those are going to be the biggest applications that you'll see predominantly, just because of the savings that you're able to gain for it, hitting those sustainability goals with your company, as well as kind of getting a little bit of kickback on some of those tax incentives if you've already been looking into that. But we're going to go ahead and continue on. And we're going to talk a little bit more about how much power do I need and what do I need to be looking at when I'm trying to decide if solar is going to be the best fit for me. I'm going to let Jimmy take over on this. Yep. And fill you guys in a little bit more.
Yeah. So how much power do I need? It's always the $1 million question. Um, you really have to start with what are your loads? Calculate all your average loads that you're using, whether that be the lift gate, power inverter for sleeper cab, um, you know, using a power inverter to, plug in your pallet jacks inside the trailer. All those devices, you really got to understand what all those loads are, and you can use Ohm's law. Um, this will be shared with you, after the webinar, but watts equals amps times volts to determine what your need is. But you still got to add in about a 10% on top of that to account for, efficiency losses. It's always kind of a good rule of thumb to calculate that 10% in there.
Now, I would say so, just for the sheer fact that, there is a lot of cabling that goes along with all of this. So you're going to see, a little bit of voltage drop. You're going to be seeing a little bit of differentiating factors depending on where you're taking your readings from. So I would say 10% is very safe.
Yeah. And more often than not, I deal a lot with the solar with liftgate application. And like I mentioned earlier, more often than not, you're probably going to have to add an additional charging system. Solar will likely not do it by itself, but it does wonders when that trailer is just sitting. Again, free energy once it's installed. So it does do a great job of supplementing an existing charging system or paired with an additional charging system. But again, it depends on what your loads are. How often you're, if it is a liftgate application, how often you're cycling the gate and how long it sits. I learned quickly not to say that solar won't do it by itself, because I've had customers that don't run the gate very often or don't utilize a load very often. And solar by itself does wonders.
Yeah.
But you still got to add, you still got to do the calculations and add the appropriate amount of solar for it to do what it's supposed to do.
Sure.
Kind of going back to the some of the naysayers out there on solar, and how it won't work or won't work for my application. With my experience, I've looked at some of those applications and just didn't have enough of it, so they really didn't get the full benefit of the solar.
Well, and then that's where a lot of the proper planning kind of going into this and being able to have an outlet to be able to kind of work through and determine, what is exactly am I shooting for? What am I trying to achieve? Yeah.
The other thing too is, again, you can't, the whole set it and forget it. The panel is out of sight, out of mind. You still gotta maintain it. You still gotta check on it every once in a while.
Sure.
We'll kind of give you some steps for that here shortly, but it does work. We've had a lot of good feedback from solar, as long as it's installed properly. Again, it starts with the install and maintained.
100%.
So for a liftgate application, this is kind of a neat little slide for you to use. We've kind of broken it down into railgate, or column lift, which typically they pull a lot more current than a tuck under. So what we've seen is calculate about 250 amps times 18 seconds. You divide that by the 3600 to get your amp hours. So that equates to about 1.25 amp hours of energy to operate a single lift, and then 0.9 amp hours for a tuck under. So you can kind of see with a 110 watt panel, with a rail lift, with gravity down versus power down. So you can get about 20 lifts with gravity down and about 10 lifts with power down. So gravity's not really using any energy, where power down is consuming more energy.
Yeah,
so you're going to get less lifts.
Yeah, and it's always safe, regardless of who you're using for your lift gate. Roughly half of what you would get out of your zero gravity or your gravity down is what you would end up seeing on your power down, just for the simple fact that it is requiring so much more to make all that happen. And typically you'll see a lot of these high cycles, in your shorter amount of shorter stop times, just because predominantly these are all going to be in your city areas where you can't actually run the truck due to all the emission laws and everything like that. So this again is going to be a way for us to kind of help calculate and kind of dial it in on what we need to be looking at when we're trying to spec out on solar.
Yep. Environmental factors are key. A myth: the warmer the weather, the better the solar works. There's a lot of other things that you have to take into account.
Sure.
Cloudy days. I cover the Northeast, so I see a lot of snow. That covers the panel. It's gonna hinder the operation of the solar if it's covered in dirt, debris, snow. But really, it's the amount of sunlight you get. Shadow, shade. That's all gonna play a key factor in how the solar operates. We have it's kind of a cool device that can be purchased. We got this off like eBay or
something like that,
Amazon, but it's just a device that measures watts per square meter. So you can hold this device. Hopefully everybody can see that. You can hold this device up and kind of whatever environment you're in, and it'll tell you, from a scale from 0 to 1,000, and typically a panel is going to go at full output. It's going to go up to 1,000 watts per meter squared. Yeah.
Right.
So you can hold this up, and and obviously don't face it towards the sun, because that's not going to give you a good reading. You want to face it how that panel's sitting, and it's going to tell you from 0 to 1,000 what you're going to get out of that panel, the way it's sitting currently.
So the potential to get out of it.
Yeah.
And another kind of a cool thing is you will pick up some residual amperage, coming just out of LED and fluorescent lighting as well. Now, you're not going to see a ton, but you would see something. It just depends on, again, the environment and what condition your panels or the weather is.
So currently in this room, which would be similar to a shop scenario, if the trailer was sitting in the shop, we're getting about 0.8 watts per square meter. That's not a whole lot. So you really need to pull that trailer out into the sun to really see any kind of current flow out of those panels.
Right.
And that'll kind of go into more of the testing portion of it. But
sure.
So another poll question for you, kind of ties into what we just talked about. When is the best time to test the solar charging system? We'll give you a few seconds to answer that one.
Almost feel like we just kind of gave them the answer. Yes.
Pretty much, but still fun to do these poll questions.
Oh yeah.
So we got a few more answering. So we'll go ahead and reveal the answer. Kind of a no-brainer, but yeah, a sunny day.
Yeah, I would have picked cloudy. I don't like to work in the heat.
But again, you're not going to, there's a lot of other variables as well. You're not going to necessarily get the full output of that solar just because it's sunny outside. The way that panel's sitting, typically on the trailer, is going to be flat. So
timing and position.
Where that sun's directed on that panel is going to play a key role. So, but yes, on a sunny day is the best time test solar. So moving on, I'll let Columbus kind of touch a little on the preventative maintenance, which again, I can't express enough the install is key. But once it's installed, you cannot forget about it. It's easy to forget about because it's, the panel is up on the trailer, out of sight, out of mind.
Right.
So you do have to do periodic checks, come up with a, something for your PMs to at least get up there on the trailer or the truck to see the current state of that panel, if it's covered in dirt or snow. Or...
Yeah, absolutely. And as Jimmy was saying, we've got to find a good method to being able to incorporate this, because again, with these panels being out of sight, out of mind, the hustle and bustle of the day, your technicians may end up seeing, 15, 20, 30, 40, 100 trailers a day, going outbound, so it's good to have a general rule of thumb to pop open the liftgate battery box, open up the reefer. If you see a solar controller in there or something that resembles a controller, climb on top for a quick second. Make sure that everything is clear of debris. Make sure your cables are intact. And then if you do have the opportunity, throw a voltmeter on there. Throw an amperage clamp on there. Make sure that you're getting some output on there. Now, again, it's going to fluctuate depending on the size of the panel or the type of application that you're in, as well as the environment. But again, we want to make sure that we're seeing something. And then I get asked a lot, can I test the panels directly? And yes, you can. So you can also go through, disconnect the main harness. Though it is in there pretty snug, you can disconnect the main harness that's going to the panels. And then with your positive and negative leads on your multimeter, you can read that voltage that is going to be put out from that panel. Now, typically, regardless of a 12 volt or a 24 volt application, just reading from that panel alone is going to read somewhere around 20 to 24 volts. And that's just the way that the integrity of that panel was structured.
Unregulated voltage, because
right.
It's not going through the controller.
Absolutely, and that's where the controller plays the biggest part in there, and being able to regulate and step down and adjust that amperage output to fit that battery's profile. Now, with some of our panels, I want to say, and correct me if I'm wrong, Jimmy, but a lot of them are temperature compensated to where they're able to read, based upon the temperature, and being able to hold some of those higher outputs depending on the weather.
MPPT has a lot of, basically MPPT, maximum power point tracking, it's always looking for that sweet spot in voltage to get the maximum amount of energy out of the panel. That's kind of the benefit and why MPPT is more efficient. And that's why we use that for predominantly all of our solar bolt options.
Right. But again, it's just common practices. Now, I've also had companies reach out and say, hey, well, how do I fit this into my PM schedule? And again, if you have the availability and the ability to do so, with every trailer PM, anytime that trailer comes in or anytime that it's going through any kind of checks, just a quick couple minutes and you're done. You just want to make sure that you're verifying that panel has output, so anywhere from 20 to 24 volts, making sure that amperage is flowing through to those batteries through your amperage clamp on either the controller side or coming through the system itself and going into the batteries. But we just want to make sure that no stone is left unturned, especially in those areas that a trailer might be visiting that is heavily wooded, that might potentially be catching some low-hanging branches and hopefully not any bridges, and just making sure that everything is working in tip-top shape, because again, all of this is designed to benefit you and your fleet, to help kind of cut back some of the stress that truck's alternator is going to have to then put out to replenish the charge going into these batteries. Now, as we start moving forward into our frequently asked questions, and again, some of this is where we've talked and touched on briefly throughout the presentation thus far. But how do I know my system is working? And again, rolling straight out of preventative maintenance into this, we already know how to do that. So you can measure the current at the output of the panels or the controller with a handheld ammeter. And then the constantly changing of current is common, and it's perfectly normal because, again, with that MPPT controller, it is constantly reading and adjusting its charge profile to maximize the amount of current that's going to be pushed into those batteries.
So did you talk about the mounting of the panels?
Nope.
Yep. So yeah, we've kind of touched most of these already, but obviously the roof. But when mounting to a trailer near the rear and in the center is best to avoid damage. We've kind of already touched on that.
Yeah, and again, a lot of these that we have, but it is always one of those key questions that will always be brought up. So being able to have it, stated somewhere other than just listening to us to talk about it, because half the time I can't understand words that come out of my mouth, anyways.
Go
ahead.
Kind of wrap it up. We kind of low on time here, but again, we do appreciate you joining this webinar today. Please stick around for a brief survey at the end. Let us know what you thought. Think about the presentation. If you have any questions, if you have any subjects that you want to hear about on future webinars, we love to get those. So, and happy to provide those to you all. But yep, stick around for the survey, and thanks for joining us.
Absolutely.